Hello, this is Cliff Hale's Milestone One video. For my milestone, I was to research the mechanical aspects, the filtration system, the civil part, and create a 3D model. So to start off, I'll start off with my research. Researched into especially the coagulation and flocculation part was a pretty deep research topic. Got some books from the library, but essentially used this book right here from John Bratby. Gave a lot of good ideas on things like how I would make the flocculation aspect and how it all kind of ties together. So here are some notes about that. Also, I guess I'll just follow along here. Solar panels. You can see some sketches that I made that helped me create the 3D model. Solar panels that we tried to put in, but were too expensive, too heavy, and we eventually went with this one. Down here, some other notes on things like motors. One of the main problems that we had when looking at motors was the torque ability. So this was one of the first motors that we were looking at. It's small, uses very little energy, and it also doesn't have Hall effect sensors, which we were hoping to be able to use a little bit. But it had a huge max speed, very low torque. To get a mechanical advantage out of that required several steps, which would take down the efficiency so much that it pretty much made this motor useless. Also, we looked at IP-rated motors that had better torque characteristics, but were extremely expensive. And the motor we eventually went with, similar torque characteristics. We were able to give it a mechanical advantage through the gearing pretty easily, but it did not have an IP rating. So it also cost an eighth of the price, or a fifth of the price of the one with the IP rating. And so we want to keep this realistic, so we went with that, and we'll be working on enclosures to make that water safe. Other things that affected what we needed to do with that was allowing the motors to be turned off. We had a problem that when you turn off the motors, the heavy solar panel was going to fall down to the side, so we came up with a counterweight idea that would use the weight of the motor as a counterweight for the solar panel, and alleviate that torque that would happen on that. Also, here's some gearing notes. So you can see there's going to be 1, 2, 3, 4, 5, 6, 7 plus stages for that smaller motor that had a 20,000 RPM speed. That was just unreasonable, so we didn't go with that one. Learning about gearing, my list of terms and things like that. Some diagrams and the ratios were important in that, and some sketches as well. We decided to go with a worm gear that is self-locking. It prevents back driving the motors when they're turned off in the solar tracking device. Here's some other sketches that I made of that. PVC dimensions, soda bottle dimensions that we'll put into our prototype, some sheet metal things that I needed to use for my 3D model. I needed to know some equations and some important terms for creating sheet metal models and things like that. Doing bends in the PVC and then knowing how much extra pipe I needed, and those kinds of things were a lot of what I researched. Also, some other things included lumber standards and things like efficiency curves of the motors. We wanted to keep efficiency as high as possible, which is in this region right here, faster motor, which is why we wanted to get so much mechanical advantage out of the motors. Was able to create a budget from the things that we gained from that, from what we got from the model. And now to the 3D model. This is Autodesk Inventor. I spent a lot of time getting to know this software. One great thing about it is that it has a crash course built in, which takes you through creating sketches, making parts and assemblies, drawings, and things like that. You can see here is the 3D model. It includes the solar panels, motors, the framework, wooden, that was requested by Ramesh, soda bottles, basin, batteries down here fit nicely. So that's an overview of it. You can see metallic braces that I was able to create. A quick glance at a few of the individual models that were necessary to build this. This is for the solar tracking frame, which was put into this model here to create the solar panel. Also to note, these holes were left in so that we could put an 80-20 aluminum frame, which you can see right here. Also connects up here, but I made those invisible so that we can take a look at what's underneath. An 80-20 frame can be put on to brace the solar tracking. Here's an example of the soda bottle model that I created. Bought a soda bottle, took measurements, and was able to create this model that became an important part of our model there. PVC. I needed to make PVC models, so I took so I got dimensions from that, from the PVC pipe standards. Also was able to create the braces. I couldn't find a model of the braces, so I got the dimensions from Home Depot and was able to recreate that from that. That required some help from, well, it required a few equations to figure out how much extra metal you need, because this goes, when you give it to a metal shop, you give it to them flat, and that's what this part down here is. And so when you bend the metal, you have to add a certain amount of extra on to the end to make it work. Here is the model of the battery. Ben sent me the specs for our battery model, and so I created that so we'd know exactly how much room we need. There is a frame generator built in to Inventor, but it does not have wood framing. So I created a library from the Lumber Standards, American Lumber Standards Committee, and took the standard lumber sizes and created a library that I was able to use in that. And there were some things that I was able to get from manufacturers, such as the gears. I did use the gearing tool, but where we weren't able to, it would have been much too hard to go, and it wouldn't be realistic to use custom gears. So started using these gears from the manufacturers that we plan to buy for our gearing systems. And so that is an overview of what I have for my milestone. Thank you.